Recording is rolling. It is Thursday, September 12th. So I posted to Google Classroom a few files for you guys. And next week is Homecoming Spirit Week. So this flyer is on Google Classroom. You want to get a closer look at that. Monday's Pajama Day, and then every day after that, ooh, we've got some fun days coming up. Also posted to Google Classroom. There's been an official club list released. So this is pretty long. I got 4 pages of clubs. Tells all the clubs, where they're going to be, what days, the whole thing. Right? Yeah, so yeah, if you guys want to see some club opportunities, this whole list is posted to Google Classroom for you guys. All right, of course, we're doing projectiles. So I have a starter question here. Involves Santa dropping gifts down chimneys. He has to figure out how far in advance to drop it. We're about to look at that one. All right, then most of today, I'll give you guys time to work on this projectile page. You guys remember yesterday, we took most of class to solve some projectile puzzles off this page. Okay, the ones I'm going to grade here, I'll leave this up over the class so you can see this, but 1 through 8, 11 through 17. Right, so I'm going to grade these, which we did one of these scenarios yesterday. Okay, I'm going to grade these, which again, we did one of these scenarios also yesterday. Okay? And then on the back, I'm just going to grade the left side of the page. Right? So these 3 pretty identical scenarios, except the numbers are different. I solved one of these in class yesterday, right? So you guys can see the steps, right? Where you have a cannon on the cliff, but also ramp up some angle. You guys remember the process for these on the back, and they're all sort of the same process. Is you got to find horizontal and vertical components of the blast velocity, right? So here and here. Right? You guys remember vertically, you're kind of blasting upwards, gravity's pulling downwards. Looks like the displacement from the top edge of the cliff to the ground below is also downwards overall. So keep track of what's positive, what's negative. Looks like I threw in a negative sign, so I'm giving you guys a direction there. Okay. Guys, if you're solving for, guys, think about this. If there's a height change, there's an acceleration, of course, because there's a gravity field, and you're solving for time, you're going to run into what math situation that starts with a cube? Quadratic. Did we solve a quadratic yesterday in class? To solve for time? Right? You guys have some multiple choice. Make sure you're on the right track. And then finally, how far across? That's a horizontal displacement question. Okay. X equals BT. Okay. All right. So, and then all the ones I'm not scoring, you guys got for extra practice if you like. Before you walk out of class today, I will get you guys your next take-home quiz. Finally, yeah, finish writing this. So right here, next take-home quiz. I'll put in your hand before you walk out the door. Let's have that due on Monday, so you have a few days to do that. My AP students also have a progress check, but if you're not AP, don't worry about that. All right, let's check out Santa delivering gifts. So here comes Santa with his reindeer, whizzing by at 99 meters per second. Just dropping gifts. He sees this house. Okay, so it's way in front of him, and he knows how high he's flying. Right? I've got 500 meters here, so he's going 99 meters per second horizontally. He's up at 500 meters altitude, right? And of course, he probably at Earth gravity, right? Would make sense. Right? So, how far in advance of this house does he have to drop this gift so that it falls straight down the chimney? I think that's how the system works, right? Something like that. So go ahead and solve that. When you know how far in front of the house, then raise your hand. Think more than that. If you know what you're doing, go ahead. If you're a little rusty on this, remember with all these projectile puzzles, there's 2 dimensions you have to think about. There's horizontal and there's vertical. And if you're plugging numbers into any equations, make sure you're keeping those variables separate. Okay? What's vertical is only vertical. What's horizontal is only horizontal. So don't mix and match variables because they're all vector values. They have spatial directions, except for one variable. Guys, there is one variable that actually is a scalar that does not have a spatial direction. Because what is the one variable that is a scalar? Time, right? Isn't it true? It takes the same time to get from here to here, whether you analyze it horizontally or vertically. Okay. So that might be maybe that's like a bridge variable, right? So okay, so I can set up an equation in one direction, either vertical or horizontal. Maybe solve for time, and then flip over to the other direction, and then finish solving it. Ooh, I think that'd be a good way.
Is it 9,900 meters away?
Ooh, not quite that far. I think you're on the right track though. About 1,000 meters. I think, yeah, think about 1,000 meters in front. All right. So, yeah, it's got a multi-step puzzle here. What's the first thing you did?
Solve for
Solve for time. And you get that from what kind of equation? Vertical or horizontal? Yeah, vertical, right? Vertical, right? So, all right. How can I set this up? I could say that height change is equal to, how do I finish this up? Could I do V naught Y T plus half GT squared, if something like that? Like if down is positive, so say it's going to go in the positive direction 500 meters, and gravity is also pulling down positive. Okay, so it can have all positive values, so that's nice. Wait a minute. Right. Guys, well, what if I change the scenario a little bit? What if instead of whizzing by on a slate, what if Santa's like flying in his Santa choppers, just hovering right there, and he drops the gift. Right, right. Compared to the actual projectile, would those two have the exact same vertical motion? And would they hit the ground at the same time? Wait, how many of you guys think they would hit the ground? So you drop a gift versus you let it fly to the side. Okay. How many of you guys think they're going to hit the ground at the same time? Yeah, same time. Okay. So what I'm trying to get at is I can simplify this formula. I don't actually need the whole thing. Guys, how can I simplify this? Because whether you drop something or if you're flying to the side, what is the initial vertical component of velocity equal to? 0. This just goes away. Right? So, and I'm really emphasizing that point because over the years I've seen so many students try to plug in. Oh, he's going 99 meters per second. That must be the initial velocity. Right? Be careful. That's vertical component. Right? The vertical component is just 0. Right? So don't mix and match horizontal information and vertical information. That's two completely separate directions. Right? So we're trying to solve for time here. I wonder here. Let me try this. I got a pretty good video going. I'm going to split my paper and solve some terms of variables on one side. H equals 1/2 G T. We're solving for squared, and then plug in the numbers on the other side. So I know it's going to be 500 meters is the drop height. 1/2. What do you guys feel like for G today? 9.8 or 10? 9.8. Sure, let's do it. 9.8, and of course that'd be meters per second squared, and then solve for T squared. You guys see this and this are identical. I'm just plugging the numbers in first over here. All right, so in terms of variables, I can times 2 divided by G. So T solving for squared would be 2H on G. And then if I plugged in the numbers first, it'd be T I'm solving for squared is 2 times 500 meters divided by 9.8 meters per second squared. If you like plugging in the numbers first, fine, you do that. Calculator time. Should I take the square root? Square root? All right, so however much time is, oh, hey, have you guys seen this a few times already in this class? Was that your reaction time lab right there? Right, drop your roller, friend catches it. How far the roller fall? Hey, what's my reaction time? Right there. Okay. Then over on this side, go T equals, let's get a hard number. So I'm doing square root. We got 2 by 500 on 9.8. All right, so this looks like 10.1 seconds. Right. Now that's not the final answer, but that's a really important middle step. Right. So we cleared all the vertical information and figure out how much time. Okay. So we know that this process, get the gift from here to here, it's going to take about 10.1 seconds. right, now what? Now what? Switch over to horizontal. Right, we're going to do a horizontal analysis. I mean, it is a horizontal type question. How far in advance of the house? Right, that's a horizontal. And hey guys, with projectiles with horizontal motion, there's only one equation you can ever use, and that's what? Does it go x equals v times t? Well, v sub x times t, is that true? See, like remember vertical, there's acceleration because there's a gravity field. So you have three kinematic equations, and depending on what information you have or you're trying to solve for, you got to juggle three equations, and this happens to be the correct one for this one. But horizontally, there's no acceleration. So there's only one equation. It's just x equals vt. That's it. Okay. All right, so we're trying to figure out how far in advance. That's this x right here. It's already set up to solve. Okay. What number goes right here? How fast is it going across the field? 99. 99 meters per second. That's how fast Sam's flying to slate. Everybody knows that, I think, right? Okay. And then for how much time is this thing falling? 10.1 seconds right there. 10.1 seconds. Seconds cancel, get some meters. So let's do that times 99. I'm getting, okay, either, it's about 1,000 meters. Bam. 1,000 meters in advance. All right, you guys can do that? All right. You guys good? On the second question. All right, you've got 8 questions so far. So there's a good warm-up puzzle. All right, so again, rest of class, go ahead and work on these projectile puzzles that we were solving a bunch of these yesterday. The only ones I'm going to score are these right here. I'll leave this up so you can have that checklist. And before you walk out of class today, I will get you guys your next take-home quiz, which is going to be due on Monday.